Hey everyone, Chang here and welcome to my channel. For this video, once again, we have another video on competition style problems. Once again, I love these kind of problem because it basically forces you in a sort of problem solving mentality. Each and every one of these problems require a different set of skills, different knowledge, but the core is still the same. Trying to understand the problem, just being creative, and worst case scenario, brute force it and you will solve it no matter what. So let's look at this problem. This is a super wordy problem and you can imagine how long it took me to just write this out. Bob borrowed money from his friend. Okay, cool. In order to pay his friend back, he gets a job. That's good. First hour he gets $10. Second hour he's paid $20. Third hour he's paid $30. Fourth hour he's paid $40. Fifth hour, he's only paid $10 again. Sixth hour, $20, and so on and so forth. So it just continues, right? So it's going to be 10 for the first, then 20, then 30, then 40. It's not cumulative in any way, right? And after the fifth one, you're only back to 10, then you go to 20, and you can assume seventh is going to be 30, and eighth is 40, so on and so forth. Now, it took him 35 hours to pay back, basically pay his friend back, right? How much did he borrow? Now, here's the thing. You can easily just do 1 hour, 2 hour, 3 hour, 4 hour, and just keep adding them all the way until you get to the 35th hour. And then by the time you get the 35th hour, you just add all the basically dollar amount together and then see what we get. And that works. That's wonderful. That's a brute force method. Let's leave that as a last resort. But we can just start with that because if we don't know what else to do, well, let's just look at it, right? We look at all the information we really need. First hour, second hour, third hour, fourth hour, fifth hour, sixth hour, so on and so forth. And the fact that it took him 35 hours to pay back his friend. Well, let's see. First hour, we have $10. Second hour, it's 20, so we add that together, right? That's going to be 30. That's cool. So 2 hours, he gets 30. But this one's a little different. Plus the third hour, it's going to be 60 now, plus the fourth hour, it's going to be 100. So total, this whole thing right here is just the first to fourth hour. But here's the lovely part. It seems to behave in a sort of pattern because the fifth hour is still going to be 10, sixth hour is going to be 20, and just by the way the problem is worded, we can assume seventh hour is going to be 30 and eighth hour is going to be 40. So we're talking about basically 4-hour increments. Right? Every 4 hours, we get how much? $100. All right, cool. That actually saves us a lot of time because guess what? After the fourth hour, that's $100. After the eighth hour, that's $200, right? After the 12 hours, $300, so on and so forth. Now we have something to work with. We don't have to brute force it all the way. We start seeing a pattern. So, if that's the case, let's just do something crazy. 35 divided by 4. The reason for that is because I want to see how many 4-hour increments occurs in 35. Well, we know, and this is one of those very interesting instances where remainder actually comes back into play, right? Normally after we learn remainder, boom, forget it, right? We're just doing fractions, we're doing decimals, nothing with remainder. But this one actually helps. So, when we divide by 4, quite simple. What number multiplies by 4 to get as close to 35 as possible, and we know that's going to be 8. Right, that's 32 right here, subtract, we have 3 here. Well, 4 can't go into 3, so basically we have 8 remainder 3. Well, if there's 8 4-hour intervals inside 35, that means that at least we have 8 times 100, right? This coming from the 4-hour interval. So we at least know there's going to be 800. Now we have 3 hours left. That's going to be the first hour, right? First of the interval again, the second and the third. So that would give us what? 10 plus 20 plus 30, right? That's what's remainder. That's the 3 remainder. Well, if that's the case, that gives us 60. So our total, how much he borrowed and was able to pay back after 35 hours, is when you add these two together. 800 plus 60 equals 860. There you go. Start off trying to understand patterns, brute force it a little, and then realize that actually we can be a little more efficient and then go about it that way. Let's look at the next problem. All right, so the next problem. 3 prime number add up to 40. What is the product of the 2 smallest prime number? Now, I'm sure there is some sort of very interesting, complicated formula, or actually it might be very simple formula that I don't even know of, right? That I can figure this out at a snap of a finger. But since I am not smart in any way and I don't know what the hell to do, let's just brute force it. Well, if we're gonna find 3 numbers that add up to become 40, what can we do? Well, 40 is not a prime, right? We need prime number. Let's just start counting backwards, right? Oh, well, 40 is not it, right? 39 is not it. 38, no. 37, maybe, right? So let's just at least mark this guy and let's just see what happens. 36 is not a prime. 35 is not a prime. 34 is not a prime. 33 is not a prime. 32 is not a prime. 31, yeah, that's a prime. So let's just look at that one as well. And then we can keep going, right? We can easily list out all the numbers and figure out different combinations and add them that way. But since we're working with 3 numbers, right? Of course, let's just start off with the biggest number and then hope that the next 2 prime numbers are a lot smaller. So there's a reason I marked these guys, right? Well, 37. If I'm looking at 37 as one of the numbers and they have to add up to be 40, there's 2 more numbers. 0 is not a prime, right, by definition. And then what do we have? We're missing just basically 3 plus 37 to get 40. Well, if 0 doesn't work, then the only other 2 numbers is going to be 1 and 2, right? That adds together to become 3. Well, here's where it gets a little interesting and a little tricky. It's very tempted to just say, all right, well, there it is, 37 with 1 and 2. But to my understanding, by definition, 1 itself is not a prime number because the definition of prime number, or usually accepted definition of prime number, is the fact that it's going to be 2 numbers, 1 times another number equals that number. So for example, 37, it has to be 1 times 37 to equal 37. So it has to be 2 different numbers, one of them being 1 and the other one has to be as something different. So if we're going by that definition, then 37 don't really work because guess what? The only combination we get is 37 and that's going to be 1 and 2 if we want to add them together. And since we already by definition rule this guy out, right? That doesn't work. So we just have to look at the next prime down. Well, these guys are all not prime except for 31. All right, well, 31, what's missing to get 40 is basically 9. 9 is missing. Well, if that's the case, if we can find 2 prime numbers that add together to become 9, then we basically found it, right? So, well, if that's the case, we're going to try to find 2 prime number, and that's going to be what? Well, not 1, well, 2. If it's 2, then it's missing 7. Is 2 and 7 prime? Yes. Boom, there it is. We have 31, 2, and 7. Add these 3 together, that gives you 40, and they're all prime. All right, we're almost done. What is the product of the 2 smallest prime number? Well, this is large, extremely large compared to the other 2, so we can definitely ignore that. Then these 2 must be the 2 smallest one. 2 times 7. 2 times 7 equals 14. And boom, just like that. Very simple. List as much as we want and then just go backwards. Try to be a little creative. Try to brute force it a little way. And then just, play around. And eventually we found, instead of 37, we found 31. And there we go. We have the answer for this one. Here's the next problem. Now, sometimes the least amount of words for a problem ends up being the most complex one. So this one, find the remainder of x times 10 to the 9th power plus 1 divided by 9. So basically this whole thing, this end result of a number, if you divide it by 9, we want to find the remainder of it. Now, of course, they would choose such a large number because 10 to the 9th power means that it's basically 8 with 9 zeros in the back of it. So we're talking about 8, 0, 0, 0, 0, 0, 0, 0, 0, 0, right? So that's this guy. And of course, with the cherry on top, we're going to put a plus 1 at the end. That's just a sort of a jerk move, but, well, what can we do, right? So, we're going to divide this whole thing by 9. And I'm going to write it differently so you guys can see what I'm planning on doing. Because while I love using that division, I guess you could say symbol or whatsoever, to write it like this actually helps me organize it a little bit. I want to see the pattern of this just to, I don't know, maybe something will show up. And then I'm going to leave that there because we have that weird +1. Maybe this would, you know, it theoretically be nice, or you figure something out, because if this is a competition style problem, hopefully something is nice, right? And this probably, it does something. Well, we'll see. So what I'm going to do is we have 8, 1, 2, 3 zeros. Oops. 0 right here. 0, 0, 0, and another 0, 0, 0. There we go. And then we're going to divide it by 9. Okay, cool. So let's just start and see what happens. It looks like something might actually occur. 9 going to 8. Can't. Go to 80. How many times? What's that? 8 times. So that means we're going to subtract 72 right here. Then we have 8. Then we carry a 0. Then we go 8 again. And then it's going to be minus 72. Okay. It looks like something is happening, right? And of course, now just by reasoning it out, we bring another 0. And then guess what? We have another 8 here. And it's going to be 72. And then you have 8. And then you keep on going if you really wanted to. But what we realize is that as it continues however many times until it reached the last 80, bringing this last 0 down, and then you do another 8, and then you subtract 72, and then you have 8 again, you don't have another 0 to bring down. So what does that mean? That means that we actually have a remainder of 8 after you finish, you know, this whole division. Well, normally, if it didn't have that +1, you're done. You found the remainder. Remainder is 8, right? But if you realize that we have the +1, technically what this is basically whatever this answer is, but we have a remainder of 8 over 9 left, because 8 divided by 9, right? Well, if we have 8 over 9 left as the remainder plus 1 over 9, that's interesting. That gives us, well, we add across, right? 9 over 9, which is still 1. Well, if that's the case, there is no remainder, right? Even though it would normally be 8, because we had that +1 at the end, and you add it all together, that becomes a whole number, a whole 1. So there's no remainder in any way, shape, or form. So even though it's this final remainder, this actually is sort of a trick question, right? There is no remainder. If we had the 1 go away, then the remainder is 8. But since it added the 1, interestingly enough, they all go away. No remainder. Remainder is 0. There you go. So a problem like this looks very complicated once we get started, though. If we don't know what to do, let's just see what the problem is asking, get started, and look at that. Nice pattern shows up. We can reason out without having to actually do all those. If you really want, you can fill all the 8s and realize that at the end, remainder 8, and don't forget little information, and then realize the final answer, remainder 0. All right, so there we have it. 3 competition style problem. And once again, I love these kind of problems because guess what? There's no predictable exact formula that you have to memorize, exact approaches to tackling problems. It's always try to understand the problem, chip away at it, and usually because of the design of it, something really amazing, such as like weird patterns like this show up that make your life tremendously easier. So I'm definitely gonna look into more competition style problems just because I love them, and hopefully you guys enjoy them too. Well, thank you for watching this video. If you haven't already, like, comment, and subscribe. See you in the next video.